Winter weather potential is increasing for the eastern United States as we head into next week. Multiple model runs overnight show energy diving south with an upper-level trough. Cold air is moving into position, and we're watching two distinct timeframes for possible snow events. Let me walk through the latest model guidance, compare what's changed from yesterday, and show you what the data is telling us about Wednesday through the following weekend. Right now, across the country, we're seeing a classic pre-winter storm pattern developing. Northern Michigan is getting snow this morning. The Upper Peninsula is measuring accumulation. Detroit started at 35 degrees, now transitioning to snow. Lake effect zones downwind of Superior and Michigan could see several inches by tonight. The Catskills experienced rapid changes yesterday, sunshine and 50s in the morning. By evening, temperatures crashed to the 20s with snow. That's the kind of abrupt transition mountains see when cold air dives. Meanwhile, the Carolinas and Georgia are experiencing temperatures in the low 80s today. Atlanta could hit 80 degrees. Last year, on January 10th, Atlanta had 4 inches of snow on the ground. The temperature contrast between now and next week will be stark. Tennessee is seeing rain. Western North Carolina getting much-needed precipitation after dry conditions. Tomorrow morning, northwest flow could bring snow flurries as far south as Middle Tennessee as cold air wraps around behind today's system. Now let's examine the model data for next week. Starting with the European model, the 6Z European run this morning extends 144 hours. That takes us through Thursday morning, January 15th. Here's what it shows. Wednesday morning, January 14th at 12Z. A trough is digging over the central United States. You can see vorticity maxima, the pockets of spin in the atmosphere, rotating around the trough axis. There's energy across the Great Lakes region associated with an Alberta clipper that moves through Tuesday night. Gulf moisture is present across the deep south, and the pattern is trying to connect these pieces. The 500 millibar height pattern shows the trough axis extending from eastern Canada down through the Ohio Valley into the Tennessee Valley. The western ridge is building over the Pacific Northwest. Surface pressure shows 1,008 millibars across the northern plains. That's the Arctic high pressure feeding cold air south. As we advance to Wednesday evening, 18Z, moisture is increasing across the Appalachian Mountains. The precipitation shield shows blue, indicating snow across elevations above 3,000 feet. The Smokies, the Blue Ridge, higher terrain across Tennessee, North Carolina, Virginia, West Virginia are seeing northwest flow snow develop. At the same time, low pressure is beginning to organize off the mid-Atlantic coast. The model shows 996 millibars at this point, not particularly strong yet, but it's developing ahead of the main cold air mass. That's the critical issue with this solution. By Thursday morning, 0Z January 15th, the European shows the coastal low at 991 millibars. Strong system, but positioned too far offshore. The precipitation shield associated with this low brings rain to coastal New England. The snow stays inland. Meanwhile, the northwest flow continues across the Appalachians. The model is consistent on significant mountain snow, 6 to 12 inches possible above 3,500 feet. Lower elevations see lesser amounts depending on exact temperature profiles. The 0Z European run from last night shows some differences. Wednesday evening, the coastal low develops slightly closer to shore, 994 millibars instead of 996. 2 millibar difference doesn't sound like much, but position matters more than intensity for snow placement. The overnight run brings the precipitation shield about 50 miles further west. Areas along the I-95 corridor see more moisture wrapping back. Still not a major snowstorm for the coast, but more impact than this morning's run. The back-end energy diving from the northwest shows better phase timing on the overnight run. Energy aloft is aligning more favorably with surface features. That suggests potential for stronger development if this trend continues. Now let's look at the GFS model. The operational GFS has been highly variable. 4 consecutive runs showing 4 different solutions tells us this is a sensitive forecast. Yesterday's 12Z GFS showed aggressive coastal development, low pressure bombing out to 970 millibars off the Carolinas, heavy snow from South Carolina through Virginia. Significant event. Last night's 0Z GFS backed off completely. Coastal low stayed weak and offshore. Most precipitation missed the coast entirely. The 6Z GFS overnight came back toward development. Not as aggressive as yesterday's 12Z, but showing a 985 millibar low off the Delmarva Peninsula Thursday morning. Snow across parts of the mid-Atlantic. This morning's 12Z GFS backed off again. Similar to the European, coastal development occurs but too far offshore for major coastal impacts. Why such variability? Let's examine the 500 millibar pattern. The GFS shows a western ridge building over the Pacific Northwest. The orientation of this ridge determines how energy can dig over the east. When the ridge axis is oriented northwest to southeast, more tilted, energy sliding down the west side of the ridge has to bend more sharply. That affects trough positioning over the eastern United States, which affects where surface low pressure develops. The GFS runs that showed big coastal storms had the western ridge oriented more north-south, less tilt. Energy could dig more directly southward. The trough over the east was positioned further west. Surface lows developed closer to the coast. The runs showing weaker coastal development have the ridge more tilted. Energy has to bend around it. The trough over the east ends up further offshore. Surface development occurs too far from the coast to bring significant precipitation inland. Small differences in ridge orientation, maybe 50 to 100 miles in positioning, cascade into large differences in storm placement and intensity. The ensemble guidance gives us probability distributions rather than single solutions. The GFS ensemble shows a spread of outcomes for Wednesday into Thursday. About 30% of ensemble members show significant coastal development. Low pressure under 980 millibars. Heavy snow for parts of the East Coast. About 40% show moderate development. Low pressure 980 to 995 millibars. Some coastal snow but not a major event. About 30% show weak development or offshore track. Minimal coastal impacts. That spread tells us the atmospheric setup supports a range of possibilities. We're not seeing ensemble consensus on one dominant solution. That indicates forecast uncertainty remains high. The European ensemble, EPS, shows similar spread. Slight bias toward offshore solutions compared to GFS, but still showing a range from significant event to minimal impact. Now let's examine the second time frame. Friday, January 16th through the weekend. The 0Z European from last night extends to 240 hours. That gives us visibility into this period. The morning run only goes to 144, so we lose this time frame's detail. Friday evening, the overnight European shows another trough diving over the eastern United States. Energy is present across the Ohio Valley and central Appalachians. The 500 millibar pattern shows continued troughing. The western ridge remains in place. Saturday morning, January 17th, shows light to moderate snow developing across the central and southern Appalachians. Not a major system on this run, but winter weather nonetheless. By Sunday morning, January 18th, some ensemble members show low pressure organizing off the coast, but the operational run keeps it offshore. A miss for the second time frame on the overnight European. The GFS extended range shows similar challenges. Energy moves through Friday and Saturday. Some members develop coastal systems, others keep them offshore. No clear consensus. What's driving this pattern? Let's look at the larger scale forcing. The polar jet stream is amplifying. We're transitioning from a relatively zonal flow west to east with minimal north-south movement to a highly meridional flow. Big ridges and deep troughs. This amplification is driven by blocking developing in the North Atlantic. The NAO, North Atlantic Oscillation, is trending negative. That supports blocking east of Greenland. When you have blocking there, it reinforces troughing over the eastern United States. The PNA, Pacific North America pattern, is trending positive. That supports ridging over western North America and troughing over the east. Both the NAO and PNA are aligned to favor this eastern trough pattern. The AO, Arctic Oscillation, is also trending negative. That allows Arctic air to spill south more readily. When the AO is negative, the polar vortex becomes less stable. pieces of it can break off and dive southward. All three teleconnection patterns favor cold and potential winter weather for the eastern United States. The question isn't whether the pattern supports it. The pattern clearly does. The question is exact timing and phasing of individual systems. Temperature guidance is more consistent than precipitation. All models agree on significant cold arriving Wednesday and persisting through the weekend. The GFS-MOS model output statistics shows Atlanta dropping from 78 degrees today to 38 degrees Thursday. 40-degree temperature drop. Overnight lows Thursday night in the mid-20s. Charlotte sees similar drops. 75 today to 36 Thursday. Overnight lows in the low 20s. Richmond drops from 62 today to 32 Thursday. Overnight lows in the teens. New York City goes from 50 today to 28 Thursday. Overnight lows in the mid-teens. Boston sees 48 today, dropping to 26 Thursday. Overnight lows around 12 degrees. The northern tier sees the coldest temperatures. Minneapolis could drop to -5 Thursday morning. Wind chills reaching -25. Green Bay around 0. Wind chills -15. This cold persists. The extended GFS keeps temperatures 10 to 20 degrees below normal through January 22nd. The European extended shows similar persistence. The cold is locked in by upper-level pattern. As long as the trough remains over the east and the ridge over the west, cold air continues flowing south. Right now, both the GFS and European maintain this pattern through at least January 25th. Snow potential for the mountains is high confidence. All models agree. Northwest flow Wednesday into Thursday brings significant accumulation above 3,000 feet. The WPC Weather Prediction Center Winter Weather Desk is highlighting 6 to 12-inch potential for the highest elevations. Gatlinburg at 1,400 feet is on the edge, could see significant snow if temperatures stay cold enough. Could see rain changing to snow if a degree or two warmer. For the Piedmont and coastal areas, confidence is low. Everything depends on coastal development that models can't agree on at this range. The ingredients exist. Cold air will be in place. Energy is moving through. Moisture is available. Whether they come together correctly to produce a significant coastal storm remains uncertain. The phase timing is critical. Northern energy diving with the trough needs to interact with southern moisture at exactly the right time and place. If the northern energy is 6 hours too fast, it races offshore before southern moisture arrives. If it's 6 hours too slow, moisture stays offshore. At 6 days out, that 6-hour timing difference is within model uncertainty. We need to see consistency over multiple runs. Right now, we're seeing run-to-run variability that suggests the atmosphere hasn't decided yet which solution will verify. Current conditions support the pattern transition. Water vapor satellite imagery shows the trough beginning to dig over the western United States. Dry air is wrapping around the backside of the ridge. That's the first sign of pattern amplification. Surface observations show cold air building over Canada. Temperatures across Alberta and Saskatchewan are 20 to 30 below 0 Celsius. That's the source region for the Arctic air heading south next week. Upper air soundings from stations across the northern plains show the profile of Arctic air. Temperature inversions near the surface. Very dry air aloft. Classic Arctic air mass signature. As this air mass moves south Wednesday and Thursday, it will modify slightly, picking up some moisture from the Great Lakes, creating lake effect snow potential. But the core cold remains intact. For today, we're dealing with a different system. Rain across the southeast. Snow across the upper Midwest and northern New England. Severe weather potential across the deep south this afternoon. The SPC Storm Prediction Center has a slight risk from Montgomery through parts of Georgia. Tornado threat exists. Wind shear profiles support rotating storms. Don't ignore warnings if issued. Behind today's system, temperatures drop tonight into tomorrow. Not the Arctic cold of next week yet, just a preview. Tomorrow morning could bring snow flurries as far south as Middle Tennessee with northwest flow. Looking beyond next week, the extended guidance suggests the pattern remains favorable for additional winter weather chances. The trough over the east doesn't quickly retreat. Even if next week's specific systems disappoint, more opportunities follow. The key is the pattern shift. We're transitioning out of the warm ridge that dominated December and early January. This trough pattern could persist into early February based on current extended guidance. For preparation, focus on what's certain. Cold is certain. Mountain snow is likely. Everything else requires monitoring as forecasts evolve. If you're in the mountains, prepare for significant snow Wednesday into Thursday. Equipment ready. Supplies stocked. If you're anywhere in the eastern two-thirds of the country, prepare for cold, the coldest of the winter. Protect pipes, check heating, winterize vehicles. For areas with uncertain snow potential, monitor forecasts daily. Model trends over the next 2 days will clarify whether coastal development occurs or stays offshore. Updates continue tonight and through the week as new model data arrives and forecasts firm up or remain uncertain.